Welcome, everyone. In this lesson, we're going to be looking at applications of derivatives and optimization techniques to a business setting. And so to really kind of get started, we're going to introduce some terminology and the functions we're going to be considering throughout this lesson. And the main functions we're going to be considering are the cost, revenue, and profit functions. So to start, the usual scenario we're going to be considering is that we're going to be investigating a company or maybe an entire industry that produces and sells one particular item. And what we're going to do is we're going to use variable X to denote the number of items that are produced or sold. And when we go through this, we're going to, in most of these, it's going to make sense to think of X as a non-negative integer. So what I mean by that is X could be 0 or 1 or 2 or 3 or, so on. But in order to do some calculus, it's going to make sense to also consider decimals. So we're going to also assume that X can be a decimal. So there will be an interpretation where X can take on kind of fractional values here, or decimal values. All right, so X is going to represent, our variable is going to represent the number of items that are produced or sold. And then the main functions we're going to be looking at are the cost, revenue, and profit functions, and we give them a good name. So our cost function is going to be C of X, our revenue function is going to be R of X, and then our profit function is P of X. And profit is actually related to the revenue and cost functions by this little formula. So it's actually the revenue minus cost. So in some way, you can think of the cost function as how much money our company would have to pay out in order to produce the items. The revenue is how much money the company would bring in. And then the profit is the difference. So how much money did we have to pay out minus how much money did we bring in minus how much money did we have to pay out. So you can think of the cost function as money out. You can think of the revenue function as money in. So it describes how much money the company actually brings in. And then the profit is, well, how much money is left over after we pay all of our costs. All right, so, and these functions can be positive or negative, especially profit here. So if the profit is, if the profit function has a positive value, well, then the company has actually made a profit in what we normally understand take the word to mean. And if the profit value is negative, well, then the company has a loss. It lost money. And so for each of these functions, there's a derivative that goes with it. And we call these the marginal functions. All right, so each function here, cost, revenue, and profit, they have a first derivative. So there's a first derivative for the cost function, there's a first derivative for the revenue function, and there's a first derivative for the profit function. And these derivative values, or these derivatives, we give them a special name. So we call them, marginal cost, marginal revenue, marginal profit. And the way we're going to interpret these, well, these are just the derivatives, the first derivatives. But the way we're going to interpret these is, derivatives tell us how much, they kind of tell us the rate of change. So what these are going to actually do is they're going to measure for us how much our profit, revenue, or cost functions change by selling one more unit, one more item. So that's what these marginal cost, revenue, and profit functions are going to do. That's what these first derivatives are going to do, is they're going to tell us, they're going to give us a way to measure how much our profit, revenue, or cost would change by selling one more unit, one more item. And this is what we're going to kind of investigate. We're going to investigate what these derivatives kind of represent. And let's start with an example. So we're going to suppose in this first example here that the cost of producing X items is given by this cost function C of X, and the units here are dollars. So our cost function here is 0.005 x cubed minus 0.5 x squared plus 28x plus 300. And for the first part, we want to figure out what the marginal cost is when x is equal to 50. So the marginal cost is just the first derivative. So all this is really asking for is find the first derivative and plug in x equals 50. So let's do that. So our first derivative, we go through and differentiate this function. So the derivative of the first term is going to be 0.015 x squared. Derivative of the second term is going to be just x, so minus x there. And then the derivative of the last part is going to be plus 28. All right, so there's our first derivative. Now, we want to figure out, well, what is the value of this first derivative when x is equal to 50? So we want to actually plug in 50. And that's what we'll do next. So we're going to take this first derivative, plug in 50, and when I do that, I get 0.015 times 50 squared minus 50 plus 28. And if I were to clean that up, do the arithmetic, I end up with 15.5. And the units here for marginal cost are going to be dollars, and we'll write it out, dollars per item. So what this units come from, where these units come from, is the units for cost are dollars, and then the units for x are items. It's the number of items. And so we know that when we do a derivative, we take the unit of our function, which in this case is dollars, and we divide by the units of our variable. So in this case, the units for C prime of 50 are going to be dollars per item. And so what this represents, what this value represents is, and let's actually interpret it. And so our interpretation is that at this production level, so at this production level of 50 units, the cost is increasing And we know it's increasing because this derivative value is positive. So the cost is increasing, and it's increasing at a rate of $15.5 per item. All right, so what would that mean if we wanted to, if we were at this production level, say we've already produced the 50 units, the 50 items here, and we wanted to make one more. So we can interpret this marginal cost value as the cost of producing that one additional item. So another interpretation of this is the cost of producing just that one extra item. So if we're at this production level of 50 units, if we wanted to make just that extra one, that one extra one, so the cost of producing just the 51st unit, we've already made the 50 units, we want to make one more, what would be, or approximately be, the cost of producing just that one extra unit? Well, it's going to be this $15 and $15.50, $15.5 here. So the cost of producing just one additional item is going to be this marginal value here. So the marginal rate, the marginal cost function, tells us if we're at a certain production level, well, how much extra would it cost us if we wanted to increase production by a few units? All right. So let's kind of keep this in mind, and we'll try another example. This time we'll work with some revenue and profit as well. So for this one, we're going to let R of X denote the revenue. Now our units here for revenue are thousands of dollars, and we're generating this by producing X number of units. And let's suppose we don't actually have the formula for the revenue function, but let's suppose that if we produce 4 units, then our revenue value is going to be 7. And the derivative of R, when we plug in X equals 4, is negative 0.5. And what we want to do is we want to use this little bit of information to estimate the additional revenue that results from increasing the production level by 1 unit. So we're going to go from a production level of 4, and we're going to increase it to a production level of 5. So we're going to go from producing the 4 units, and we're going to produce one extra one. What would be our change in revenue in that case? And so the change in revenue, this change in production, well, that's what our marginal revenue function represents. So the change in revenue is going to be approximately this derivative value. So that's what derivative is allowing us to measure. It allows us to measure the change in revenue going from X equals 4 to X equals 5 by increasing our production level by 1 unit. So if we increase our production level by 1 unit, that's approximately our derivative value. And so in this case, it's just going to be the negative 0.5. And to kind of put this in a different context, this is going to be negative $500 because the value here is for revenue is thousands of dollars. So this negative 0.5, if we convert it into from thousands of dollars into just dollars, is going to be negative 500. And so what we see here is that if we were to increase production, if we're currently at the production level of 4 and we wanted to produce one additional item, well, that change in revenue is approximately our derivative value here, the marginal revenue function. And that value is negative 0.5, which written another way is negative $500. And what this tells us then is that the revenue decreases. By $500. All right, so this doesn't look too good. If we're at a production level of 4 and we decide let's increase production by one more unit, let's produce a 5th unit. Well, our revenue is going to go down by $500. All right, so let's kind of use this information then to estimate the revenue that's generated by producing 5 units. So the revenue, really what we want to do is we want to estimate R of 5. That's really what this question's asking here. Estimate the revenue generated by producing 5 units. Well, the only information that we have is that we know the revenue generated by producing 4 units, and then we know we have a good estimate for what would happen if we increased production by 1 unit. We have this marginal revenue function. And so this revenue, when x is equal to 5, the revenue generated by producing 5 units, is going to be approximately equal to the revenue generated by producing 4 units plus our marginal revenue at x equals 4. So this first value tells us our revenue by producing 4 units, and this tells us what how our revenue would change by producing 1 additional unit. So this is our revenue at x equals 4. And this value represents how much our revenue changes by producing one additional item. So if we take kind of our revenue where we are at x equals 4, and then we add to that the change in our revenue from producing 1 additional item, well, that's going to take us up to the revenue generated by producing 5 units. And so if we add these two values together, what do we get? Well, we get 7 plus negative 0.5, and that ends up being not negative, but it goes down. It goes to 6.5. And so the revenue is approximately $6,500. So it's approximately $6,500. So what's happened is at this production level of 4, our revenue was $7,000, and by increasing production by 1 unit, our revenue decreases by $500. So that means our revenue, if we go up to that new production level of 5 units, our revenue is going to be approximately $500 lower. So we're going to be at a revenue value here of $6,500. All right, so we can then see if our company is going to make a profit at this new production level, and we can take into into account the cost function if we know the cost associated with producing 5 units. And so in this case, we do have a cost function. So it's this x plus 4 over x plus 1. And this cost function gives us the cost in thousands of dollars that it takes to produce X number of units. And so we want to know, does the company make a profit at this new production level? So the profit function, if we remember, is the revenue, how much money we bring in, minus the cost, how much money has to go out, that we have to pay out. And so for our purposes here, we want to know, do we make a profit at a production level of 5 units? So essentially, we want to figure out what is our profit value at x equals 5. And so we can take our newly found revenue value at x equals 5. We have a good estimate for how much money our company brings in using that marginal revenue function. And then we can figure out, well, how much money do we have to pay out? And now this we have an explicit function for, so we can just plug in. All right, so what do we find? Well, for the revenue function, we know that R of 5 is approximately 6.5. So this is going to be an estimate after all. A good estimate, but an estimate nonetheless. So 6.5 is going to be our revenue value at x equals 5. Then we're going to subtract, and let's figure out what the cost is going to be at this new production level. So we're just going to plug 5 into our cost function here. So we get 5 plus 4 over 5 plus 1. And if we kind of try to simplify this down, we get 4 over 6. And if we get a common denominator here, what do we end up with? We end up with, well, 6.5 minus, and if we get a common denominator between these two terms, we end up with 34 over 6. And if we kind of keep going with the arithmetic there, we end up with a value that's approximately 5.667. And if we kind of, no, that's the cost. We end up with a profit value that's approximately 0.833. Excuse me. So this cost value, if we were to get this as a decimal, or this 34 over 6, this would be approximately 5.667. So either of those, if you simplify them down, you get something that's a little bit bigger than 5. And then if we take that decimal and essentially subtract it from our revenue, the 6.5, we end up with a value here that's approximately 0.833. And what this tells us is that our profit at a production level of 5 units is excuse me, is approximately $833. And remember, our units here were thousands of dollars. So if we convert this decimal into just dollars, we end up with this 833 value. And so what we see here is that even though the revenue decreased by $500 by kind of increasing our production level, and conceivably the cost increased. So that's not particularly good when the revenue decreases and then the cost increases. But even with all of that, we're still, the fact that this value is positive tells us that we've actually still made a profit. We haven't made a loss. The company hasn't made a loss yet. So even at this new production level of 5 units, our profit is still positive, and it's approximately this value of $833. All right, so where we're going to go with this is we're going to be investigating, these profit and revenue and cost functions, and we're going to put them in the context of optimization. And so we're going to interpret, and we're going to see how we can use our optimization techniques to maximize or minimize cost, revenue, and profit functions. So we'll start that in class. We'll see you then. Bye-bye.